In this lecture, we will talk about the forward propagation. We saw that the data transfer from input to the output is known as forward propagation. Since we have million of points and this working is inefficient, so we need to have some notation so that we can use that and find the answer. For example, we could have 9 hidden layers, then this notation will not work. So what we do, we start from input and reach at hidden layer, okay, from hidden layer to the output. Okay, the first thing we need to understand is when I say that W, which is a weight, it has a superscript 1, then this means that this one is hidden layer 1. And if we have in the subscript 1 1, it means that this weight is defined from input 1 to the hidden layers neuron 1. I hope you got the point. Just to give you a visualization, suppose we have input that is x1 and x2, and we also have three neurons in the hidden layer, and there is output. If I just want to change the notation, since in future I will be working in matrices as well, so if you start from x1 and reach at neuron number 1 in hidden layer, the notation for that will be, the new notation will be weight for hidden layer 1, and it is going from 1 to neuron 1. So that will be 1 1. And suppose we have this value from input to the hidden layer neuron number 2, that notation will be hidden layer 1, since this is hidden layer 1, and the link is from input 1 to the second neuron in the hidden layer 2, hidden layer 1, the second neuron in hidden layer 1. I hope you got the point. Similarly, we also have, and you do the same just to make sure that you understand, you do the same for all the other values, and you do the same from here, then here, then here, so on. You have to change the notation. The first value you get, not the exact value before applying the activation function, we have Z, which has superscript 2, and we have 1 1, which shows that the value is from input 1 to neuron 1, and this value will go to the 2, that is 2. Okay, and similarly for this we have 2. Just let me just revisit that again. This one is, people use it differently. This one is the weights for the input. Let's revisit that. So this is your input, and the input name is 1. Then we have in hidden layer, and that name is 2. This is 2. We need to just revisit that again. And then we have 3. So one shows that we are taking weight from x1 to the neuron number 1 in hidden layer 1. Although this look like it is 2, but that's how it is. It is hidden layer number 1. Okay, I hope you got the point. Similarly, if the weights are coming from this neuron 1 to the output, then we will write the weight is coming from 2. This is just a name, not the hidden layer. And since we have only one output, so that will be only 1 over here. Similarly, when we draw a weight, we take a weight from second neuron in the hidden layer, that will be number 2. This is not hidden layer. Previously I said it is hidden layer, but it is not hidden layer. This is just a name of second layer. And for that, W2 is 2. And the same goes to the third neuron in hidden layer 1, but in notation it is, for example, W2, and then we have 3. Okay, I hope you are not confused from this notation. So we were talking about that the first value you will get over here is Z, the value of Z in the layer number 2, and the value is coming from 1, from input x1, and it is for the first neuron in the hidden layer. And that value, when we apply f of z activation function on that, we get a, the value for 2, a11. So that value becomes a211. Similarly, this value becomes a212, and that value, the third neuron in hidden layer 1, and the layer number is 2. We have a 2 and 1, the input from 1, and it is 3. Okay, 1 to 2 and 1 to 3. That's what we have. And we already defined the weights for the output. And here you get, since this is the output, Z3 will be equal to Y hat after applying the activation function. Let me just write the formula for this updated notation. Z211 can be obtained. The 2 means we are in layer number 2, and 1 means the input 1 and the neuron number 1 in the layer number 2. That value can be obtained by x1, w11, x2, w211. I write all the other values. The value in layer number 2 and 1, 2 is, this is 1, 1. 1, 2 is input 1 to neuron number 2 in layer 2. That will be x1 w1 1 2 plus x2 w1 2 2. And I continue for layer number 2. We have 1 3, and we have x1. The weight is coming from layer number 1, which is input layer, 1 3 plus x2 w1 2 3. How we get a2 value? Since we did not apply activation function over here, the activation function is a. When we apply the activation function, we get answer for layer number 2, A211. We apply any activation function, Z211. That will be equal to, now here we apply, for example, sigmoid function. Uh, uh, how the sigmoid function is defined? It is defined like this: f of z is equal to 1 over 1 plus e raised to power minus z. So it means that we need to put this value into that value in z. So we get 1 plus e raised to power. Since we don't know the value, we replace the value of z11 with all the value on the right hand side. So we get minus x1 w11 plus x2 w1 to 1. We put that value over here. We get A211. Similarly, we get A212, the value obtained by applying the activation function Z212, and we have 1 over 1 plus e raised to power minus x1 w121 plus x2 w1 layer number 1 to 2. That's it. Okay. This is the sigmoid function. Okay. Then we similarly can write A213. I think you can just see that how the value can be replaced in the activation function Z213. Whatever the activation function you can choose. So here we get all these values. Now Z3 will be equal to A112 layer number 2, and the weight is W12 plus A122 W22 plus A213 W23, and finally the answer can be obtained in the output y hat by applying the activation function Z3. We have 1 over 1 plus e raised to power minus z. We put the value of z3. It should be z3. It means the third one is the output. So we have 1 plus e raised to power minus a112 w12 a12 w22 plus a213 w32. Okay, that's what we have output. So this is the general notation that we need to understand, since in future, as I already said, that we will work on the uh, in the vectors and in the matrices. For example, here we have this value. This can be write it as w1, and w1 will be equal to w11 w112. This is the vector form. We will talk about that. So every book has different notation. Some people use one as a layer and hidden layer, so on and so forth. So here in this case, this one, we denote it as layer number one. This is layer number two, and this is layer number three, which is output. Thank you for watching.